Okay, 11.2b. In today's lesson, we will be finding the sum of a series. And again, a series is the sum of a sequence. So you have a sequence, and you are just adding all of the terms of the sequence. Okay, again, we have that summation notation, and then we have our formula. Okay, we got S sub n, which is saying the sum through n terms. The sum through n terms. Okay, so n being the number of terms that you're adding up through, times a1 plus a sub n, so whatever that a1, the first term of the sequence, or series, a sub n, meaning the last term that you're trying to add through, divided by 2. That is one formula. I typically like to use S sub n is equal to n over 2 times a1 plus a sub n. I tend to use that. I think it's a little bit easier. Either of them work. They're equivalent. So, looking at it. Find the sum of the series. Not arithmetic. Okay. Look at it again in a summation notation. This part right here is our rule. Okay, that is what's going to help us find our terms. And then we have our lower limit again, which is 5, upper limit of 10. Meaning I'm finding the sum of the 5th term through the 10th term. Now, when you don't start with the first term, it's typically easier to start with just that first term that you're adding through. So we need to find A5, A6, A7, A8, A9, A10. Now in a situation like this, typically you could use the formula, but then you have to use it twice and subtract one from the other. It's a little bit more difficult than just finding each term, adding it up. So when I'm finding these terms again, I'm going through A5. That means I'm taking 5 and I'm plugging that into I in this case. So 5 squared plus 1. For A6 is 6 squared plus 1. 7 squared plus 1. 8 squared plus 1. 9 squared plus 1. 10 squared plus 1. Okay, so 25 plus 1. 36 plus 1. 49 plus 1. 64 plus 1. 81 plus 1. 100 plus 1. So 26, 37, 50, 65, 82, 101. Now we did do this, I believe, in the very first notes of chapter 11. And it gave us a total of, let's see, just bear with me for a second. $361. So again, since it is a series, it's just adding those terms up. In this case, we had to add A5 through A10, so you have to find those terms. Just plugging the 5, 6, 7, 8, 9, and 10 into the general rule, getting those terms, and add them up. Okay, find the sum of the series. Okay, again, the summation notation is an indicator that this is a series, and it's saying I'm adding the first term through the 6th term. A1, A2, A3, A4, A5, A6. This one's pretty easy because just plugging 1 into the general rule, it's just 1. Plugging 2 into the general rule, 2. So on and so forth. Adding those up. 3, 6, 10, 15, 21. So again, it's saying add the first term through the 6th term. So you need to figure out those terms, add them up to get us a total of 21 there. Okay, once we get a little harder. Okay, so in this case, it is saying find the sum of the series, and we're finding the sum of the first term through the 34th term. A little bit, I don't want to write out 34 terms and add them up. That's going to take a long time. This is where that formula of S sub n is equal to n over 2 times a1 plus a sub n. Okay. So, in this case, it's saying find the sum through the first 34 terms. 34 is going to be our n. So I'm finding S sub 34. So that's equal to 34, no, not 32. 34 divided by 2 times the first term plus a sub 34. So what I need to do is I need to still find that first term, and I need to find that 34th term. Again, if I want to find a sub 1, all I'm doing is plugging 1 in for I. So 1 plus 8, or 9. A 34, 1 plus 8 times 34. So 1 plus 272, or 273. So now I'm taking these, 9 was the first term, plugging that into the first term. 273 was the 34th term, so I'm plugging those in. So I got S sub 34 is equal to 34 divided by 2 over times 9 plus 273. Go ahead and plug that into the calculator. Okay, it ends up being 17 times 282, or 4,794. So again, when we get to these series where we're adding a lot of terms together, using the formula is going to be much easier. Because I'm not going to write out 34 terms and add them up. It takes a lot of time to do. So, find the sum of the first 18 terms. So again, that's saying find S sub 18. So we're finding the sum of the first 18 terms of the arithmetic series 100 plus 110 plus 120 plus 130. Now, what's always going to help find the general rule. Okay. To get to the next term, we're adding 10. Okay, so 10n, and then again plus a sub 0. Again, remember dn plus a sub 0. Common difference in this case is 10. If I was to go to a sub 0, which would be just subtract 10 to go that way, that's going to get us 90. So there's our general rule. Now, so S sub 18, remember it's n over 2. So if I'm finding 18 through the 18th term, it's 18 over 2 times the first term, which we are given in this case, plus a sub 18. Now, a18, we don't know what that is. I mean, you can work all the way through 18, or you can use this general rule. Much easier if you do that. A18 is equal to 10 times 18 plus 90, or 180 plus 90, to give me 270. So, S sub 18 is equal to 18 over 2 times 100 plus 270, which gives us a total of 3,330. Now, a little bit harder. Find n for the series such that S sub n is equal to 600. So, if we think about our formula, S sub n is equal to n over 2 times a1 plus a sub n. Now it says find n. So now I don't know what n is, but I do know what the sum is. I want the sum here to be 600, so I'm going to replace S sub n with 600. So we say 600 is equal to n over 2. And then I also know what a1 is. a1 is that first term, it's up here, of 100, plus a sub n. This is the tricky part of it. Okay, I can write the general rule in place of a sub n. So 10n plus 90. Now we have an equation where we have n in there, and that's the only variable, meaning we can solve for n. So just taking it one step at a time, 600 is equal to n over 2 times 190 plus 10n. Okay. To take care of this 2, I'm going to say let's multiply both sides by 2. Okay, that way we don't have to work with fractions on the right side. We can just say 1200 on this side is equal to n times 190 plus 10n. Distributing our n through, 190n plus 10n squared. Okay, again, that is a quadratic. We're taking everything to one side, so I'm going to bring that over there. So it's going to be 10n squared plus 190n plus 1200 equals 0. Okay, let's move up here. I can factor out a 10 out of all of that, so 10 times n squared plus 19 minus 120. Looking at that, I see that it can factor. 10 times have to be n. They have to be opposites. Thinking what can multiply and get 120, 24, and 5. So plus 24 minus 5. So I get solutions of n equals 24, negative 24, sorry, and n equals 5. Now, thinking about this, find n for the series such that s of n is equal to 600. If in a sequence you don't have a sub negative 1, a sub negative 2, so having a negative answer on a question like this does not make sense, but having an answer like this does. N equals 5. What that is saying, through the first 5 terms, so A1, A2, A3, A4, A5, which we were given 4 of them, and finding the 5th one is pretty easy. So 100, 110, 120, 130, 140. The sum of those adds up to 600, 500, plus 10, plus 20, plus 30, plus 40, which it does. So if it's a small number like that, it's a quick, easy check if you just write out those terms. Okay, sum should be 600. Add up that 100, 110, 120, 130, 140. I get 600, meaning we're good to go. Okay, just like this is a problem from, I think, the second day of sequences and series. I said that we have a formula, which we do have for it now. So, S sub n is equal to n over 2 times a1 plus a sub n. Okay, so if we have the summation of the first term through the 250th term, that's a sum of s sub 250. So 250 over 2 times the first term, which would be 1, and the last 250th term. It's pretty easy in this case. Just plugging it is 250. So then 125 times 251, which gives us a total of, let's see, 125 times 251. 31,375. A little bit easier than writing out 250 terms and adding them up. Okay, so the assignment for this lesson under Chapter 11, homework 11.2b. Make sure you are completing your homework If you have any questions, make sure you are asking. Now, one thing I do want to just specify, when using this formula here, this is for arithmetic series. So again, we need to look at the general rule and notice that it's arithmetic. That's when we can use that formula. All right, have a good day.